Artificial intelligence is already all around us, quietly working in the background of our daily lives. It is the invisible engine that helps you search the web, finding exactly what you need in a fraction of a second. It is the friendly curator that suggests which movie to watch next on a Friday night. It learns your tastes better than you might know them yourself. It is the co-pilot in advanced vehicles, making decisions to keep you safe on the road. In the next 10 minutes, you can gain a foundational understanding of what this powerful technology is and how it functions. This essay will serve as your guide, breaking down the world of AI into simple, understandable concepts. This exploration is designed for everyone, regardless of your technical background. You do not need to be a programmer. You do not need to be a mathematician to grasp the core ideas that are shaping our future. We will peel back the layers of complexity and look at AI not as digital magic, but as a tool built by people. We'll show how it uses data, and we'll explain the clever algorithms behind it. By the end of this brief read, you will understand the terminology you hear in the news. You'll also have the confidence to try a simple AI tool for yourself. Let's embark on this short but enlightening journey to demystify one of the most transformative technologies of our time. Our goal is not to turn you into an AI expert overnight. Instead, we aim to provide you with a clear and accessible map of this fascinating landscape. We will start with a simple definition, we'll walk through its history, and we'll explore the key concepts that make it all work. You'll see concrete examples of AI you're likely already using every day, the virtual assistant on your phone, and the system that filters spam from your email inbox. The world of AI is not a distant, futuristic concept. It's a present-day reality becoming more integrated into society every day. Understanding the basics of AI is becoming as essential as knowing how to use the internet. It empowers you to be a more informed user. It helps you become a more critical thinker. It encourages you to be a more engaged citizen in a world driven by automated decisions. This knowledge helps you appreciate AI's potential to solve major global challenges. It also makes you aware of its limitations and the ethical considerations that come with its development. So, take a deep breath, clear your mind, prepare to learn the fundamentals of AI in the time it takes to enjoy a cup of coffee. Okay. At its heart, artificial intelligence, or AI, is a branch of computer science dedicated to creating systems that can perform tasks that typically require human intelligence. Think about the skills you use every day: learning from experience, recognizing faces in a crowd, understanding spoken language, making plans, solving new problems. The grand ambition of AI is to enable machines to perform these kinds of cognitive functions. It is not about creating conscious beings with feelings as often depicted in science fiction. Rather, it is about building practical tools that can process information and make intelligent decisions or predictions based on that information. It is crucial to understand that AI is not a single entity or a monolithic force. It is a broad field encompassing many different methods and technologies. When we talk about AI today, we are often referring to narrow AI, which is designed to perform a specific, well-defined task. The AI that recommends songs, translates languages, plays chess, is a specialized tool, exceptionally good at its one job, but incapable of doing anything else. It operates based on mathematics and complex algorithms, not genuine understanding or consciousness. People are the ones who design these systems, feed them data, and set the rules and goals they must follow. To make this more concrete, imagine you are teaching a child to identify different animals. You would show them pictures, pointing out this is a cat, this is a dog, and so on. After seeing many examples, the child learns to recognize the patterns, whiskers, floppy ears, tails, that distinguish one animal from another. AI, particularly a subfield called machine learning, works in a very similar fashion. Developers teach a computer by feeding it vast amounts of data, such as thousands of labeled images of cats, allowing the machine to learn the identifying patterns on its own, without being explicitly programmed with rules for catness. So, when you hear the term artificial intelligence, do not immediately picture a walking, talking robot from a movie. Instead, think of it as a powerful method for solving problems. It is a way for computers to analyze complex data and find patterns that would be impossible for a human to detect manually. This capability allows us to build smarter applications that can see, hear, speak, and even create in ways that were once confined to the realm of human thought. AI is ultimately a set of tools, and like any tool, its power lies in how we choose to build and use it. To understand modern AI, it is essential to grasp a few core concepts, starting with machine learning, ML. As we touched on earlier, machine learning is the primary engine driving most of today's AI advancements. Instead of a programmer writing explicit step-by-step instructions for every possible scenario, they instead create an algorithm that can learn from data. Imagine trying to write rules to identify a spam email. You could write if the email contains free money, it's spam, but spammers would quickly adapt. With machine learning, you simply feed the algorithm thousands of examples of spam and non-spam emails, and it learns the subtle patterns on its own, becoming far more effective and adaptable. Within the world of machine learning, a popular and powerful model is the neural network. This concept is loosely inspired by the structure of the human brain, which is made up of billions of interconnected neurons. A computer-based neural network consists of layers of interconnected nodes, or neurons. Each neuron receives inputs from other neurons, performs a simple mathematical calculation, and then passes its output to the next layer. When the network is being trained, the strength of the connections between these neurons is adjusted over and over again, until the network's overall output accurately predicts the correct answer for the training data. Deep learning is simply a more advanced and powerful form of this approach. The deep in deep learning refers to the use of neural networks with many layers, sometimes hundreds or even thousands. These deep networks are capable of learning incredibly complex and abstract patterns from massive amounts of data. For example, in an image recognition task, the first few layers of a deep network might learn to recognize simple features like edges, colors. Middle layers might combine these to recognize more complex shapes like eyes, noses. The final layers can then assemble these features to identify a complete face. This hierarchical learning ability is what makes deep learning so exceptionally powerful. In summary, you can think of these concepts as nested dolls. Artificial intelligence is the broadest category, the overall field of making machines smart. Machine learning is a specific approach within AI that focuses on learning from data. Neural networks are a type of model used in machine learning, inspired by the brain's structure. And finally, deep learning is a technique that uses very large multi-layered neural networks to solve highly complex problems. It is this deep learning technique that is behind many of the most impressive AI breakthroughs you see today. Realistic voice assistants, self-driving cars. That's it. The dream of creating intelligent, non-human entities is as old as human storytelling itself. But the scientific pursuit of artificial intelligence began in earnest in the mid-20th century. The 1950s marked the official birth of the field, with pioneering computer scientists like Alan Turing exploring the question of whether machines could think. The term artificial intelligence was coined at the 1956 Dartmouth Workshop, a summer conference where a group of visionaries gathered to lay the groundwork for a new discipline. These early AI programs were based on logic and rules meticulously handcrafted by programmers, allowing them to solve simple puzzles and play basic games like checkers. The initial excitement of the 1960s and 1970s gave way to periods of slower progress and reduced funding, which came to be known as AI winters. Despite these setbacks, important theoretical work continued. In the 1980s and 1990s, a new approach, called machine learning, began to gain traction. The true revolution arrived in the 2000s and accelerated in the 2010s, fueled by big data, GPUs, and breakthroughs in deep learning. This combination of ingredients finally unlocked the potential that early pioneers had only dreamed of. Suddenly, AI systems could achieve, and in some cases surpass, human-level performance on specific tasks like image recognition and speech transcription. This recent progress is marked by several key milestones that captured public attention. In 1997, IBM's Deep Blue computer defeated world chess champion Garry Kasparov, a symbolic victory of machine calculation over human strategic genius. In 2011, IBM's Watson competed on the quiz show Jeopardy and won against two of its greatest champions by processing natural language. Perhaps most significantly, in 2012, a deep learning model won a major image recognition competition by a stunning margin, heralding the modern era of AI. Then, in 2016, DeepMind's AlphaGo defeated the world's top Go player, a feat once thought to be decades away due to the game's immense complexity and reliance on human intuition. Okay, so that's the brief history. You might be surprised to learn how often you interact with artificial intelligence throughout your day. It is not some far-off technology. It is woven into the fabric of the digital services you already use. One of the most common examples is the recommendation system. When Netflix suggests a new series based on what you've watched, when Amazon shows you products frequently bought together, that is AI at work. These systems analyze your past behavior, your clicks, purchases, and ratings, and compare it to the behavior of millions of other users to predict what you might like next. They are constantly learning and refining their suggestions to keep you engaged. Another ubiquitous application is the virtual assistant, Apple's Siri, Amazon's Alexa, and Google Assistant. When you ask, "What's the weather like today?" a multi-step AI process kicks in. First, speech recognition technology converts your spoken words into digital text. Then, natural language processing algorithms analyze the text to understand your intent. Finally, the system retrieves the requested information and uses a text-to-speech engine to deliver the answer in a human-like voice. This seamless interaction is a symphony of different AI models working together in perfect harmony. AI is also a critical component in the development of autonomous vehicles, or self-driving cars. These vehicles are equipped with an array of sensors including cameras, radar, and LiDAR, which generate a massive constant stream of data about the car's surroundings. Deep learning models process this data in real time to perform a multitude of tasks simultaneously. Identifying pedestrians, identifying other vehicles, reading traffic signs and signals, staying within the lane markings, and planning a safe and efficient path to the destination. While fully autonomous driving is still a work in progress, the underlying AI technology is already making cars safer through features like automatic emergency braking and lane-keeping assist. Beyond these high-profile examples, AI operates behind the scenes in countless other ways. You do not need to be a programmer to get a hands-on feel for what AI can do. The internet is filled with free, easy-to-use demonstration tools that let you interact with powerful AI models directly from your web browser. A great place to start is with an image recognition demo. A quick search for online image recognition demo will lead you to several websites where you can upload a photograph. Find a picture on your computer, perhaps of your pet, a flower from your garden, a landmark from a recent trip, and upload it to the site. Once you upload the image, the AI will analyze it and, within seconds, provide a list of labels or tags that it believes describe the contents of the photo. It might identify dog, golden retriever, grass, park. This process gives you a direct window into the capabilities of computer vision. To make it more interesting, try challenging the system. Upload a more ambiguous image, like an abstract painting or a close-up of an unusual object. Observe the labels it generates and think about why it might have made those guesses or mistakes. This simple act reveals both the power and the limitations of current AI technology. Another fascinating and accessible demo is a web-based chatbot. Search for a simple chatbot demo or an AI chat tool. Finally, you can easily experiment with speech and voice AI using the virtual assistant already on your smartphone, or a free online, speech-to-text demo. These quick, code-free demos transform AI from an abstract concept into a tangible experience, giving you an intuitive understanding of its real-world applications. Now it is time to put your new knowledge into practice with a simple, step-by-step exercise. This activity gives you a structured way to interact with an AI tool and reflect on its performance. We'll focus on a widely available chatbot for a dynamic conversational experience. Your goal is not just to use the tool but to observe it like a scientist, noting strengths and weaknesses. This hands-on approach builds intuition for real-world behavior. Step 1. Find and greet a chatbot. Open your web browser, search AI chatbot demo, or search chat with an AI. Choose a free public option. No sign-up needed. When the chat loads, start with a simple greeting. Type hello and press enter. Type hi there and press enter. Pay attention to its initial response. Is it generic? Is it friendly? Is it professional? Step 2. Test its factual knowledge. Ask a clear factual question. What is the capital of France? How many planets are in our solar system? Try a slightly obscure fact. What was the top-grossing film of 1988? See if it finds the correct answer. Step 3. Request a creative or planning task. Ask for a creative or planning output. Write a short 4-line poem about the ocean. Help me create a simple workout plan for 3 days a week at home. Check structure. Check coherence. Check usefulness. Does the poem make sense and follow a rhythm? Is the workout plan logical and safe? Watch for flaws or nonsensical suggestions. Verify before following. Step 4. Reflect on the interaction. After testing, reflect. Where did the AI excel? It was likely good at retrieving facts. Where did it struggle? Creative writing felt generic. Advice too vague. Did it ever give a confidently incorrect answer? That's called hallucination, a common limitation. This exercise should make clear what AI can and cannot do today. While the potential of artificial intelligence is immense, it is equally important to approach this technology with a clear understanding of its limitations and the safety considerations involved. AI models are powerful tools, but they are not infallible. One of the most significant challenges is that AI systems are only as good as the data they are trained on. If the training data contains historical biases, gender prejudices present in text from the internet, racial prejudices present in text from the internet, the AI model will learn and can even amplify those biases in its outputs. This can lead to unfair or discriminatory outcomes in areas like hiring, loan applications, criminal justice. Furthermore, AI models, especially large language models, do not understand information in the way a human does. They are incredibly sophisticated pattern-matching machines. This means they can sometimes generate answers that sound plausible and confident, but are completely incorrect. This is often referred to as an AI hallucination. For this reason, you should never blindly trust the output of an AI for critical information, such as medical, legal, or financial advice. Always verify important facts with reliable primary sources. Think of an AI as a brilliant but sometimes unreliable assistant. Its work always needs to be double-checked. Privacy is another major concern in the age of AI. Many AI applications require large amounts of data to function, and sometimes this includes personal data. When you use free AI demos or services, it is essential to be mindful of what information you are sharing. Avoid uploading sensitive personal documents, private photographs, confidential business information to unknown or untrusted platforms. Always read the privacy policy if you are concerned about how your data might be used, stored, or shared. Using AI responsibly means being a cautious and informed digital citizen. The development of AI also raises broader ethical questions for society to consider. How do we ensure that AI is used for good and not for malicious purposes, like misinformation, autonomous weapons? How do we handle job displacement as automation becomes more capable? Who is responsible when an AI system makes a mistake that causes harm? They require ongoing dialogue among technologists, policymakers, ethicists, the public. In the span of just a few minutes, we have journeyed from a simple definition of artificial intelligence to the powerful deep learning models that are reshaping our world. We have seen that AI is not an abstract futuristic concept, but a tangible and pervasive technology already integrated into our daily routines. Movie recommendations, virtual assistants. By demystifying terms like machine learning and neural networks, we have replaced the idea of digital magic with a more grounded understanding of data-driven algorithms. Your hands-on exercise with a chatbot was more than just a simple test. It was your first step as an active and critical user of AI. You have now experienced firsthand both the impressive capabilities and the notable limitations of these systems. By continuing to learn and stay engaged, you become part of the movement to ensure this powerful technology is developed and deployed responsibly for the benefit of everyone. Your journey into the world of AI has just begun. Keep exploring, keep questioning, keep learning.